Sure.
Hi. We are all curious cats. I think we've all tried at some point or another to open a refrigerator door slowly to see if when the light inside turns off and on. And we've all been amazed by how automatic doors open and close without us needing to touch them. And more recent refrigerators can even be called smart, with touchscreens and all kinds of internet integration. So how does all this computation fit inside a refrigerator or doors without needing to fit a fully sized computer inside? Well, I'm here to tell you about the functionality of microcontrollers. Knowing about the functionality of microcontrollers highlights their versatility when performing small tasks when compared to fully sized computers. Microcontrollers provide a simple, bite-sized way to program things. I will discuss the pins of microcontrollers applications in circuits, and their applications in real-world appliances. So how does a microcontroller know what to do? Well, it needs to be told what to do. Microcontrollers have three important types of pins. You can make these pins do things by sending them signals and computer programs. From the article, Microcontrollers, the Basics, from the ITP Physical Computing class at New York University in 2023, microcontrollers can be described as a connection between the physical world and the digital world. So when you click on a mouse or keyboard, it sends signals to a microcontroller, and that microcontroller can display stuff on a screen, for example. From the same ITP class in 2023, they provide microcontroller pin functions, which explains dedicated voltage pins and ground pins, which ground serves as a zero for the voltage to create power. To send more complex instructions to microcontrollers, John Foxworth's How to Program a Microcontroller, written in 2015, published by Michigan State University, explains how to upload computer programs using an integrated development environment, using C++, for example. These programs consist of two important steps: variable declaration, where you assign values to objects which you send to the microcontroller, and reading and writing, where the microcontroller takes those variables and communicates with its pins, which then send signals up to somewhere else to do something. So in short, the pins that line the outside of the microcontroller can be told what to do using all kinds of signals and computer programs. So earlier I alluded to voltage. Well, microcontrollers can be put into circuits to tell other things what to do. The reason some pins on a microcontroller have the letter V on them is because they provide reliable voltage sources according to Ohm's law. But you can actually go above the number that's labeled if you need to. But according to Ohm's law and microcontroller GPIO on stratifylabs.dev, written in 2016, all input-output must follow the basis for building DC circuits, which is Ohm's law, which can be described as voltage equals current times resistance. An example on stratifylabs.dev explains that if you have a circuit with a resistor and an LED and a microcontroller, you have 3 volts in that circuit, the LED can take away 1 volt, but you need to get rid of the other 2 volts using the resistor to keep the microcontroller safe. And that's where you set the equation. It's 2 equals current times resistance. And if you need more power out of the microcontroller, well, Les Pounder's How to Overclock and Underclock a Microcontroller, or Overclock and Underclock a Raspberry Pi Pico, written in 2023, published by Future US Inc. explains that a Raspberry Pi Pico can up to double its factory performance, and you can conserve energy if you're using it as a battery. But keep in mind that you need to still follow Ohm's law to keep the microcontroller safe. So, in short, reliable voltage allows you to make use of Ohm's law, and microcontrollers can be overpowered and underpowered. So what can a large power source such as a home or a battery provide a microcontroller? Well, microcontrollers have recently become a mainstay of STEM education and real-life appliances. In education, you can use microcontrollers for fun little science projects, and in the real world, you can use them to add smart functionality to all kinds of home projects. Microcontrollers can be used to create things like sensors and Internet of Thing objects, as can be found on howtoelectronics.com's Raspberry Pi Pico W projects written in 2024. On this site, you can find projects such as soil moisture monitor, an LED control, and a web sensor weather station. And on a larger scale, Bennett University's What Are Microcontrollers as B-Tech ECE Specialization and What Types of Other Applications explains that microcontrollers can be found within things like radios, TVs, heart rate monitors, 3D printers, and Wi-Fi extenders. So, microcontrollers can be used in all kinds of educational and professional environments. So what do microcontrollers tell us about technology? Well, microcontrollers represent the versatility to perform smaller tasks that fully sized computers cannot. Today, we learned about pin functions, circuit applications, and real-world appliance applications of microcontrollers. So now, anytime you go out into the world and see something like a motion sensor, you'll look at it and you'll think a microcontroller is at work.